Next, we are going for a note. Note: necessary and sufficient condition to be satisfied by the parameters for the existency of the BIBD are not known. Thus, in a BIBD, we assume that V is greater than K, lambda is less than R. If lambda equal to R, then the second relationship, that is lambda V minus 1 equal to R K minus 1. Then we get here lambda equal to R. Then here in the place of lambda we can write R, right? Then R V minus 1 equal to R K minus 1, which implies V minus 1 equal to K minus 1, which equal to V equal to, which implies V equal to K. That means number of treatment equal to number of plot. Number of treatment equal to number of plot. This is the case of randomized block design, right? In this case, the design is a randomized block design. So now we start intra block analysis of balanced incomplete block design. Intra block analysis of balanced incomplete block design. Here consider the model. What is the model for BIBD? Yi j equal to mu plus alpha I plus beta j plus epsilon ij. Equation 1. Here I from 1 to V, j from 1 to B. Here Yij denote observation in the jth block receiving the ith treatment. Mu is the overall effect. Alpha I is the effect due to ith treatment. Beta j is the effect due to jth block. Epsilon ij is unobservable error, which is distribution as normal 0 sigma square. So we can write the model 1 in a matrix notation, that is expectation of y equal to a theta. Equation 2. The model 1 we can write it as a matrix notation, that is expectation of y equal to a theta, where a dash a equal to, what is a dash a? We are R E 1V K E 1B R E V1 R I V and K E B1 and transpose K I B, right? Then what is theta there? Theta equal to, there is a parametric vector, right? Theta equal to mu of order 1 cross 1, alpha of order v cross 1, beta of order b cross 1. So theta is of order v plus b plus 1 cross 1. Here the model 2 is Gauss-Markov linear model, where n equal to, what is n there? N equal to VR. And number of parameters p equal to v plus b plus 1. And it is a particular case of incomplete block design. Then we can find out the C matrix of BIBD. The C matrix of BIBD is, what is C matrix? C equal to R minus N K inverse N transpose, right? Here what is R? R equal to diagonal of R, so on R of order. We can write it as R I V. Here V times R, right? So we can write it as R into IV. And also, what is K there? K equal to diagonal matrix of K, so on K, right? You can write it as K into IB. So here, what is R? R equal to small r into IV minus, we can write N K inverse N transpose as N into N transpose divided by K, which is equal to R IV minus, we know the value for N transpose, right? That is R minus lambda into IV plus lambda EVV, right? Which is divided by K. This is the value of N transpose, right? Which is equal to, then multiply, then rearrange the terms. That is, you can rearrange these terms together. Then you can write R minus this R minus lambda divided by this K N into this IV. Then here minus, right? Minus lambda EVV divided by K. EVV divided by K. Then here cross multiply, that is RK minus R minus lambda, or R plus lambda, here minus, so plus, divided by K into IV minus lambda EVV divided by K, which is equal to here RK minus, which is equal to 1. Then we can write this term as R into K minus 1, this term RK minus R equal to R into K minus 1, right? Plus lambda divided by K into IV minus lambda EVV divided by K, which is equal to, we know that from relation 2, that is lambda V minus 1 is equal to R K minus 1, right? So we can write lambda v minus 1 instead of r k minus 1. So here we can write lambda v minus 1 plus lambda divided by k into iv minus lambda evv divided by k, which is equal to lambda v minus lambda plus lambda divided by k iv minus lambda evv divided by k, right? Is equal to, here lambda lambda could cancel, lambda v divided by k iv minus lambda divided by k evv. Then we will take common term outside, that is lambda v divided by k is equal to iv minus, here evv divided by this, here no v terms, right? Then here v. So symmetrics of BIBD equal to lambda v divided by k iv minus evv divided by k. Here what is iv? Iv is a identity matrix of order v cross v. This is C matrix for BIBD. C matrix for BIBD. Where what is iv minus evv divided by v? Where iv minus evv divided by v equal to 1 minus 1 by v minus 1 by v, so on, minus 1 by v. 1 by v. Here minus 1 by v. The second value is 1 minus 1 by v, so on, minus 1 by v. Similarly here minus 1 by v, second value is minus 1 by v, so on. The last value is 1 minus 1 by v. Observe that here sum of each row in the matrix is 0. So therefore the rank of iv minus evv divided by v, which is less than or equal to v minus 1. Equation 1. Here sum of each row is 0. So the rank of iv minus evv divided by v is less than or equal to v minus 1. If r1, r2, so on, rv are the rows of iv minus evv divided by v, if r1, r2, so on, rv are the rows of the matrix iv minus evv divided by v, then a2 r2 plus a3 r3 plus so on av rv equal to 0, then which gives minus 1 by v summation I from 1 to v ai equal to 0. Star is a star equation. Here is a sum of is a column total except the first row, that is minus 1 by v summation I from 1 to v ai equal to 0. And we can write the jth equation from this matrix, that is, and 1 minus 1 by v aj minus 1 by v summation I 2 to v. Here also, here this is the column total except the first row. Then it will become I from 2 to v is equal to 0. Equation star. And here the jth equation, that is 1 minus 1 by v aj minus 1 by v summation 2 to v ai equal to 0, where j from 2 to v. Then subtract star equation from this jth equation. Then you can get, subtract star equation from this jth equation. Then you can get 1 by v aj plus 1 minus 1 by v aj equal to 0, which implies 1 by v aj plus here aj minus 1 by v aj equal to 0. Then this term got cancelled, which implies aj equal to 0 for all j from 2 to v. Therefore, the last v minus 1 rows are independent. Therefore, the last v minus 1 rows are independent. That is a2 r2 plus a3 r3 plus so on av rv equal to 0, which implies aj equal to 0 for all j equal to 2 to v. Therefore, r2 r3 so on rv are linearly independent. Here aj equal to 0 for all j equal to 2 to v. Therefore, r2 r3 so on rv are linearly independent. Therefore, we can write rank of v is greater than or equal to v minus 1. Equation 2. From equation 1 and 2, we get a rank of c equal to v minus 1. From equation 1 and 2, we can say that rank of c equal to v minus 1. v minus 1. It is we know that one lemma, right? That is rank of c equal to v minus 1. Then that design is said to be connected, right? Here, this is rank of c in here in case c is a matrix of C matrix of BIBD we are taken, right? So rank of C equal to E minus 1, then you can say that BIBD is connected design. And what is the rank of a design matrix A? We know that rank of a design matrix A is rank of A equal to B plus rank of C, right? So here rank of BIBD model is B plus rank of C, right? Which implies B plus here rank of C equal to V minus 1 here. Therefore, the rank of BIBD model is B plus V minus 1. If any question is like find obtain C matrix for BIBD and find its rank and show that it is connected, then this is a similar proof. You should find out first C matrix, and also you have to find rank of C equal to V minus 1. Also find, if in the question is asked find out the rank, then you should also write this term also. Okay, then next one lemma 1, that is BIBD is a connected design. The proof is similar in the above. That is, the C matrix of BIBD is, what is the C matrix? C equal to C matrix of BIBD equal to C equal to lambda V by K into IV minus EVV divided by V. And what is the rank of C matrix? Rank of C equal to V minus 1. So we can say that rank of C equal to V minus 1, which implies that design is connected. Here is the rank of C matrix for BIBD, right? Then we can say that BIBD is connected design. BIBD is